Welcome back to Space Vidcast live coverage of the final flight of America's Space Shuttle. I'm here with John Kerry, the director of Dream Chaser program, and you come from a NASA background a bit.
That's right. I worked 24 years at NASA.
Wow.
Started in 1987, right after return to flight of the Challenger accident. So my first flight was STS-135. I was a shuttle flight controller. Originally, my first job was kind of a silly one. It was sending up text messages. So you guys are doing all this fancy stuff now, IT. Well, back then it was a 63-character ASCII set that you had to send up over ground sites, every time the shuttle went overhead. But as a rookie coming right out of Texas A&M University, I thought it was pretty awesome. And did that for many years. I went on from a flight controller to work with the Russians for many years. Spent a lot of time in Russia in the Mission Control Center there, both on the Mir program and the first element of the space station. I was the lead flight director. When I became a flight director, I started in 1998 as a flight director. And so I was originally in Moscow for the whole first piece of the space station we put up. Bob Cabana, who was the boss here at Kennedy Space Center, was the commander of that flight. And then did that for 10 years, and it was a great experience.
Culture different between Russia and the U.S.? A little bit difference in how they run the space program?
Very different, but the job's the same. When I started working with them, they called us you winged vehicle people because they didn't think we got space station. And they said, you winged vehicle people, you just don't get it, because we had done a lot of long duration space flight, and we had learned about all the effects of the human body and those kind of things. We knew how to get through the atmosphere up and get through the atmosphere back down. But when you put those two cultures together, it was a wonderful experience, and it changed me forever. Because I learned there were more innovative ways to do things, that there are different ways to solve problems, especially in a cost-constrained environment. My first trip to Russia was in 1994, right after the Soviet Union fell. And it was a totally different, they were on life support. And it's not much different than where we are with NASA today, in the sense that there's just a lot less money to go to this kind of endeavor, and that's fundamentally why the shuttle's been retired. There's nothing wrong with the vehicle. It's a wonderful flying machine, and we're going to miss it a lot. But the Russians taught us how to do that, and it taught me, and after I came back from working in Russia and being a flight director, and then my other jobs since then, it's taught me that there are ways that you can design and develop and test and build vehicles much cheaper.
And that led you eventually into Dream Chaser.
Right. Actually, the first three, the finished shuttle, my last lead shuttle flight was STS-116, which flew in late 2006. And in 2007, actually, I worked on Orion for about 3 years as Orion Vehicle Integration Manager. A great experience. But then after the cancellation announcement, I went to commercial engine to work for the Dream Chaser guys, and that's been wonderful because I've got all this information from my Russian experience, from my U.S. experience, and you got a winged vehicle that can actually bring 7 people up and down very effectively, and so trying to see if we can do that much cheaper.
I've seen the mock 7 people.
7 people.
It seems really tiny. Now, don't get me wrong, the Space Shuttle crew compartment, most of the Space Shuttle is cargo, but the stuff I've seen with Dream Chaser, you can really fit 7 people in there?
Yeah, you can fit 7 people in there, and it's actually not that bad, because, the shuttle, there's a flight deck and a mid deck.
Yep.
Okay, on Dream Chaser, just basically the whole cabin is one cabin environment, so that the amount of space that there is in there to put 7 people isn't that bad. It's what we call net habitable volume. So you can still do all the things that you need to be operable, to manipulate the ship, to get the job done. If you had to do an emergency egress, you can get out fairly effectively. Dream Chaser being a winged vehicle, you can actually just run out the back end. What in the shuttle side is a payload bay. Well, that's enclosed. You just go out the back end, open the hatch, and you're gone. So 7 people fit in there pretty good.
Oh, you
come see the mock-up.
You winged vehicle people, yeah.
Yeah, exactly.
So this is one of the few winged vehicle replacements. When you're looking at the commercial crews or commercial vehicles going that are bidding to go up to the International Space Station, you've got Orion, which is a capsule like the Apollo era. You've got Dragon, which is a capsule like the Apollo era. Very few companies are actually doing winged vehicles. Why did you guys opt for wing as opposed to capsule?
Well, I think both of them have important jobs. And Orion is is sized for going to the moon, an asteroid, things like that. So if you're going, mass matters, when you start talking about getting into space. And so if you're going all the way to the moon and back, you need to be as light as possible. And so, wings are really wasted in the vacuum of space.
Sure,
right?
yep. Mm-hmm.
So where wings do their job most effectively is low Earth orbit, right above us.
Mm-hmm.
And so then you can bring the crew back and science from the space station. The space station is now a national laboratory. Well, because just like shuttle, we're landing, very gently. So you're pulling less than 2 Gs through the whole thing and landing on a runway where you can then get to the science and the crew can be in a deconditioned state and on their back, and it's very safe for the crew. So we felt like that the winged vehicle was an excellent methodology to do that. Somebody asked me a long time ago on capsules versus winged vehicles. There's 2 different jobs. A capsule, that's more of a rescue vehicle type of thing, or like I said, coming back from high velocity, having that conical shape is very useful. And you're right, we're the only winged vehicle. We're better, very good as a taxi service to bring up people and cargo and science to be utilized to go jump and fly. To get protein crystals, you land at the runway over here on the Kennedy Space Center, which is what we're planning to do. And you just go grab that stuff, and it didn't go through the shaking and all the other loads that you see coming through on the re-entry profile that you get off of the capsule. Because capsules are pulling 4 to 6 Gs, nominal. Ballistic re-entry is even more than that, more like 8.
Wow.
Versus 2. That's fundamentally the difference. So our taxi service ability is really, I think, what makes us. And then from a NASA perspective, I think it's good to have multiple views. Just like, are we replacing Soyuz or are we replacing Shuttle? Because basically Soyuz is now going to do the job for a while until an American company can come in and take it over. So there's already commercial work going on. We're just giving the money to the Russians, right? So all of us here at Reisman, I know, was just here talking, for SpaceX and the Boeing guys and Blue Origins and us. We just want to be able to do that on the American side so that the seats are actually purchased, with American investment in what we're able to do, and then we can move on commercially.
Yeah, this is kind of it's a bittersweet moment. It's a sad moment for the Space Shuttle to be retiring, but, it does open up the possibilities to move away from a space program into a whole new space industry. We can kind of reinvent how we look at space by moving to privatized space companies such as yourself. What's your view on the shuttle being retired? You mentioned earlier that it was good for a bunch more flights, which is correct. They were designed for 100 flights over the course of 4 to 5 years, not 25. But what's your view of the shuttle as it is today versus kind of what you're doing at Dream Chaser?
Well, like I said, we just can't afford it, and so every shuttle flight costs over $1 billion, and so that's a very expensive endeavor, and the amount of money that NASA has available is less. So what is NASA's job? I worked for NASA for 24 years. NASA's job is exploration. And so how do we enable the possibility for NASA to explore? The way to enable that possibility for NASA to explore is to hand over the job of routine access to what NASA's been very good at doing for 40, 50 years, right? So getting between here and the space station, NASA can do. It's time to hand that over to the commercial crew folks so that job can be done commercially with business investment at a much cheaper rate. Because we're all in a business. We're trying to make money, so we're trying to make it to where you and I can fly, right? And I think that's going to happen. It's just a matter of when and which company actually does it the fastest. And so NASA then can go explore, and they can go off to the asteroids. The multi-purpose crew vehicle, which is right sitting over here. That's its job. Its job isn't to go to the space station and back. We can do that. It's not hard. There's technology that gets everybody up and down from the space station. We're riding on an Atlas V rocket, for example. 96 flights in a row without failure. That's a big deal. Maybe 97. So that's a very reliable rocket that's flown many, many, many times. So the technology is not new. So we took technology that NASA took up to the point of certification and then applied it. Our vehicle looks a lot like Shuttle, DPS, the Thermal Protection System. Shuttle's right? And then the X-37 stuff that's all cool. So that's what, there should be a division. NASA should explore, build the multi-purpose crew vehicle, build a heavy lift capability, because that's what we need to get beyond the Earth orbit. And then let the commercial guys do that job so that you and I, maybe, or maybe our kids, 10 or 15 years ago can have a chance to go to Bigelow's space station, or whoever has come up with that. Air flight was just the same way. You know, they didn't, in the inertial stages, there was no Southwest Airlines. Southwest Airlines didn't exist. To make that enabled, there was the Airmail Act. The government gave money through the Airmail Act to move mail, and the government paid for that. And it turned into an industry that now you probably got here riding in an airplane.
I did, as a matter of fact, yep. So you know what we're going to do? Really awkward. I want to get more volume out of you because it's getting louder out here. So I'm going to do a quick mic change if you don't mind. Sure. Just clip that off, clip this bad boy on. Live internet. That's why we're not broadcast. Awesome.
This one better?
We'll find out in a moment. So you're talking about kind of where we can go in 10 to 15 years. Is now the right time for this transition?
Absolutely. I mean, with the dollars that we've got, and what's really good for the taxpayer on the commercial crew thing is it's fixed price contracts, milestone driven. So the government gets to invest a little bit of seed money and says, if you make this amount of progress so that we can actually buy seats from you, then we'll give you more money. But we're only going to give you more money if you succeed in the milestone. They don't have to pay us unless we meet what we committed to meet. That's a big deal as a taxpayer. So you don't end up with, well, we broke the bank, we had trouble making, you know, this thing turned out to be more expensive, so we need you to give us more. So that's in this cost-constrained environment where the budget, you know, the amount of discretionary funding for the thing that I believe in and I think you believe in, that's why you're here, space flight is something that is core to all of our beings. We have to find a way to do it more cheaply. That's the way to do it.
Are you guys going to concentrate mostly on NASA bringing up traditional astronauts, or are you going to open up space to more common folk? You talked about in 10 years, you know, I got here on an airplane. When can I go? When can I fly on one of your...
It could be shorter than 10 years. So we're trying to get the first launch in 2014, 2015, depending on how much funding we get, you know, from NASA and other investments. So with that first flight, now remember I mentioned that this initial Dream Chaser that we were building has 7-person capability. The NASA guys only need us to carry 4 to and from the space station, at least 3 seats. What should I do with those 3 seats? I think we would sell them to folks that want to ride, just like the Russians do today. They've flown tourist astronauts to the space station many times. Dennis Tito, one of the times I was lead flight director, Dennis Tito was brought up as the first tourist astronaut to the International Space Station. He paid the Russians to do that. So we will sell those other 3 seats, absolutely.
I call shotgun.
and the problem is trying to get the cost down, how much it costs to do it, because I think the Russians charge somewhere around $30 million or so for a tourist to go, and so we need to get it down so that you and I can, I don't know, maybe you got $30 million.
Oh, around, if I had $30 million, I guarantee you this would look a lot different than it does right now.
So, but that's the future. Right, is to get the number down. Just like airline industry talked about, the seats used to be very expensive, and then after the business case takes over, all of a sudden you fly more often. So that's another thing we want to do in terms of the thing is the number of flights per year. If we can get the flight rate up, then it gets the number of the cost per seat down. And that's the other thing we're trying to do is fly to the space station or to Bigelow or to wherever else anybody else has come up with more frequently.
Is that a deadly trap to fall into? Because that was you just kind of mentioned the same thing that the shuttle that was promoted. You got to get the flight rate up, we'll drive the cost down. Flight rate up, cost down. And what ended up happening was they started getting the flight rate up, and they started going faster and faster and faster. People started burning out. They started taking, I don't want to say shortcuts, and then, you know, between their 2 shortest flights ever, a 16-day interval, boom, Challenger. And from there, everything just tumbled out of control. You know, costs went way high, flight times went way low. The vehicle, as magnificent, beautiful as it is, and I'm sitting here watching it launch. I'm sure you're going to have a great time watching it launch as well. I'm sure you've seen a ton as a flight director. It just never lives up to its potential.
Okay, so it's a very good question. So what's between what happened through my whole career with shuttle and what we had? That's a very complex, wonderful, but very complex flying machine. So when all the requirements that NASA's levying on us, and actually we're levying on ourselves, because it's not good business for you and I to get killed if we were to fly in this thing, right? So, you know, in Southwest Airlines' best interest of people. So we are going to have to meet the safety standards they've got on there. So one of the requirements they levied fundamentally turns into, we want you to be at least 10 times safer than shuttle. So one of the core tenets on every single commercial endeavor is a launch abort capability. Shuttle doesn't have that. So shuttle is sitting right up against the side of all rocket motors and external tank. It's got stuff that's falling down from it that hurt. That's what happened to the 107 crew. The SRB burn through is what took out that vehicle. They're side mounted. We're sitting on top. Sure. So we can abort. So if the rocket blows up, we've got an abort system that can get you away and get you back on a runway. All of the commercial endeavors have that as a core tenet. It's a requirement. So there's a safety feature, as an example, that has been added into the vehicle. The other thing in terms of making the costs is that we have obviously studied, and we've got all the folks, like United Space Alliance is one of our partners, all the lessons learned from what made a shuttle so complex, especially in the ground turnaround stuff, like the thermal protection system. The size of our vehicle is smaller than shuttle. It's the shuttle is a DC-9 size vehicle, worth the feet from nose to tail, right? It's as much as cold in the people and some cargo, like you said. So the amount of PS that we've got is 1/100th of the acreage of the shuttle. The way we process it, we took all the lessons, what they improved in 135 missions. Here's how to do that faster, better. The X-37 that's just flown, those kind of things, taking advantage of what's the latest technology in that. We don't have any hypergolics. We don't have hydrazine on our vehicle, so we had a clean pad, clean approach. So when you land, it's nitrous oxide and rubber is what's used.
Hydrazine being the highly volatile toxic chemical that you see. You see it shooting. It's a nighttime shot. So shooting out of the tail of the orbit.
So when you land back on the ground, that stuff's still there, and so people have to walk up very carefully, and they have to have all that stuff to deal with those tox hazards. We don't have any of that because it's really nitrous oxide. It's laughing gas from a dentist's office and rubber, right? And so as our propellant system, I mean, it's just rubber, literally. And so you've got the rubber mixing with the nitrous, so you have to actually ignite it to get it to do the thing that it needs to do to push you through space. So those kinds of things, accessibility, how quickly we can turn around, all of those things we're incorporating so that what Shuttle was trying to do, and turned out to be too complex, frankly, from a safety perspective, how do we simplify the vehicle so that its ground turnaround is much, much better? And we're making good success with that.
How close are you to making this truly real, applying the vehicle? You mentioned 2014, but what will it take to get from here to a test vehicle?
We are working through the CCDEV2 program. We're working on taking the orbital vehicle to what we call the preliminary design review level. So by next May, we will have the vehicle of the orbital vehicle design at PDR. And then you just go, about a year from now from CDR, and then you can fly in 2014 or 2015. What we're doing in terms of tangible progress on flight testing that the public will see is about a year from now, we are going to do the first drop tests of the Dream Chaser, what they call the engineering test article, to be dropped from White Knight 2 and drop down and land on a runway so that we can do a proactive demonstration that the vehicle, this is an old NASA design that was done, called the HL-20. So we want to prove it out and actually build the vehicle, and the first version of it doesn't go to space, like I said, but it's dropped from 45,000 feet and then brought down to the runway. That gives you a lot of confidence that the system is on the right path. So we're doing both of those things here within the next year. So that gets you to 2012. Then you do more testing with, like our company built the rocket motors for Spaceship 1 and Spaceship 2. That's another good burgeoning market for commercial, Virgin Galactic, with scaled composites. And they're doing the suborbital market. Well, our motors, we can do the same thing, drop it and fire the motors, get the vehicle up to 100,000 feet in 2013 and land on a runway again. Both auto land without having crew interaction or manually piloted, so that if you had an incapacitated crew, you still get home, getting back to safety features. And then the orbital vehicle would be built after that, and it's all how much funding is going to be available to do all of this. Both we're investing money as a company as well, so it's not just coming from the government. So you get some from the government and some from our own company and our partners to put in to try to get this thing built and flown in the 2014, 2015 time frame. All of us are shooting for that.
So to sort of simplify this, you can almost look at this as Shuttle Junior. Because if you search, Google images for HL-20, HL-20, I mean, it really is. It looks like a really miniature space shuttle.
Actually, to me, it looks even more like a next generation version of shuttle. The shuttle's a delta wing, and it's got the wingtips over on the edges from the HL-20, and it's a very stable design. So the Shuttle Junior is a good way of saying it, because the fundamental capabilities are the same except for how much payload you can take. What we're going to miss about Shuttle, since STS-135 is about to launch, is its capability to carry huge cargo in that payload bay. We don't have that. We can do the people, and we can carry some stuff, inside the cabin, but it's nothing compared to what Shuttle was able to do.
But I think one of the things we learned from all the different mission reports that came out of Shuttle was that we don't necessarily want one vehicle that does crew and cargo. You should have a vehicle that does cargo and a vehicle that does crew, and it doesn't mean that they have to be two completely different designs, but they shouldn't necessarily go up on the same launch.
That's right.
That does actually make a little bit of sense.
And that's why I think having a wing vehicle, you mentioned, since we're the only wing vehicle now in this out of the last 4 that are in CCF2 right now, I think that's a good thing for NASA. I think it's a good thing for the American people.
Where can people get more information?
We have lots of information available on the website. Obviously, Sierra Nevada is our company. We're not as good because of the where their heritage is about where all the information is. So SNC is what So I think you can go SNCcorp.com, SierraNevadaCorp.com is about our company, and then the product line for us is Exploration Systems. So that's where you can find out about Dream Chaser, and as well as the rocket motors that we're building out of Poway for Spaceship Two, so there's information there as well. I think that'd probably be the best place. Also, NASA.gov, since we're one of the companies with NASA, NASA has a lot of stuff on NASA.gov that talks about the Boeing design and the Dream Chaser design and what we're doing for the Commercial Crew Development Program.
So, I was mentioning earlier, it's bittersweet, and before I let you go, it's kind of exciting to see some of those old designs that NASA was unable to bring to fruition for political reasons or non-technical reasons. Good, great designs that maybe should have seen the light of day, but now, because we're moving away from a single program into a full-fledged industry, we have competing companies capable of possibly bringing this to market. I mean, you have to deal with the likes of SpaceX and
SpaceX, obviously. Capsules look very similar, and that's why we grabbed the HL-20. It's a good design. There's nothing wrong with it, and I think the fact that NASA's investing in us tells you that the design is good. Well,
John, thank you very much for coming on the show and giving us a quick glimpse into the future. This isn't the end. This is just the beginning.
And it really is. And then, so here, 3-4 years from now, I hope we're going to be sitting here watching the Dream Chaser go off on top of the Atlas V and landing on the runway.
It doesn't have to be an Atlas V. You can go on another rocket.
We can go on another rocket.
So if they decide, we're done with the Atlas, and you want to go Delta IV Heavy, for example, you could. Yeah,
Delta IV Heavy is probably more capability than we need. But would it fit on a Falcon? Yes, probably. Would it fit on the Liberty rocket? Probably. To make it faster, to get there, we picked a particular architecture with the Atlas V because it works well and it's very reliable.
But you're not locked into that. So after the rocket, you can just.
As any business, you had a problem with that one, what's the fallback? Everybody's doing that.
John, thank you very much for your time.
Very glad to be here.
We're going to send you guys back at the TV. We are about 30 minutes away from hitting our T-minus, but we're actually around 1 hour and 45 minutes from the actual launch. We'll be right back with more guests at Space Big Cast coverage of the flight of the America Space Shuttle.